Alright, today we're going to continue looking at this word problem with a ball being thrown up and down. Today we're going to look at part B, where we need to find the velocity when it's 5 meters above the railing. So this picture here kind of shows what we're working with, so we can start by first identifying what we need to solve for. And in this question they want us to find the velocity at the y position equal to 5 meters. Next we can identify our givens. So in the question it gives us the initial velocity equal to 15 meters per second, and we have our reference height yo equal to 0 meters. Then we can identify the equations needed to solve. So we're going to need the position equation, which I've written first, and we also need the velocity equation here, which is number 2. So the next step is to draw a diagram. So we have the ball's motion here, and we identified the height of 5 meters. And if we draw out velocity vectors, we can see that there are 2 points where the ball is going to be at a height of 5 meters. And we can also see that the direction of these 2 velocity vectors are opposite to each other. That means we're going to have 2 solutions for this problem, one negative velocity and one positive velocity. So the next step is just to solve. So I just want to know, we need the velocity. So this is the velocity equation here. We have the initial velocity, we have the acceleration, we don't have the time. And so we need to find the time when y equals 5 meters. That means we have to start with the position equation. So if we start by writing down the position equation, then plug in the values we already know, which is y equals 5 meters, y initial is 0 meters, initial velocity is 15 meters per second, and then acceleration is negative 9.8 meters per second squared. We get this expression here, and then if we do this multiplication, 1/2 times negative 9.8 is negative 4.9, and then we can also bring the 5 meters over to the other side, and then we get this expression here. And since there's a t squared and a t term, we're going to need the quadratic formula to solve. So in our case, we're going to be solving for t, and this is the quadratic formula here. And then if we remember the standard equation, y equals ax squared plus bx plus c, we can identify what a, b, and c is in our equation. So if we compare the standard equation to our equation here, and if we remember for us, the independent variable is not x, it's t. So a is going to be equal to negative 4.9, b is going to be equal to 15, and c is going to be equal to negative 5. So we can plug a, b, and c into our quadratic equation, and we get this expression here. And then we can evaluate what's under the square root. So negative 4 times negative 4.9 times negative 5 is just equal to negative 98. And then 15 squared is equal to 225. So if we plug those values in, we get this expression here. And then we can evaluate what's under the fraction, get negative 9.8, and then we can also do the subtraction here and get 127, and then plug those in and get this expression here. We can then evaluate the square root, and it's approximately equal to 11.3. So if we plug that in, we get this. And if we look at this expression here, we can see that we have 2 answers for t. So we have the positive one, which is when t is equal to negative 15 plus 11.3. And the answer is going to be 0.38 seconds for the time. And then there's the negative one where we do negative 15 minus 11.3. And the answer is going to be 2.68 seconds. So these 2 answers represent the time when the ball is at a height of 5 meters. So we can look at it graphically here with the ball's motion. And we can see this point here is going to be the smaller time, t equals 38 seconds. And then this point here is going to be the larger time.